Ladies and gentlemen, in this MP4 file we are going to discuss 3-point problems, and we try to overcome the difficulties that a large part of the class apparently had with this exercise. In fact, this exercise is not too different from the exercises we did before. In both cases we are dealing with planar geological contacts or structures that intersect the topography of a terrain as we see it here. We see here the contour lines in blue, and in black we see this intersecting structure, and we see the intersection occurs at fairly high angle with the topographic contours. It runs up to this hill, it runs down into the valley and up onto the next hill, and here in the block diagram we see that this structure is indeed a planar surface that shows such an intersection with the topography, and of course the topography is a much younger geological feature than the geological structure itself. You have learned in two exercises how to interpret such contacts, and you know how to construct these strike lines by just finding intersection points between the geological contact and the respective contour lines. Here the red one has 3 intersections, also 3 intersections for the yellow, the strike line AV 260, and the AV 240 has 2 intersections here close to the bottom of this valley. You also have learned how to determine the dip directions and the dip angles from such data. 3-point problems are now just the other way around. In 3-point problems we have a situation that is much more commonly experienced during field mapping. Not all areas are perfectly exposed, and if you are dealing with planar structures or contacts of different rock layers in such a terrain, you might not find complete exposure, but you might find exposure of such a contact or planar structure in a number of places, for instance 3 places in such a terrain, and these places might be anywhere in this area, wherever you are lucky enough to find this structure, this contact of geological interest. And certainly it is very unlikely that these positions where exposure is provided by erosion or by other processes, it is unlikely that these 3 places are just along strike or along the dip direction of such a planar layer or structure. So you can assume wherever your terrain is exposed enough, or wherever your geology is exposed enough to see such a structural contour, well, that can be a random distribution of such 3 points. Nevertheless, we can construct the strike and the dip direction of such a planar layer from at least 3 points at 3 different altitudes. And we can also, from this information, determine the approximate position of the whole outcrop line, where we could find it, provided that we might dig away a little bit of regolith or soil that might hide the outcrop line from being well exposed. So we can construct that using the 3-point technique, the 3-point rule, and this is obviously highly valuable skill that might help you to target the position of such an outcrop line, even if you cannot see it in poorly exposed areas. You will at least know fairly precisely where you have to look for this outcrop. The requirement that it necessarily must apply for the 3-point rule to be valid is that the strike and the dip angle of the layer or the structure is uniform in the area of interest. So let's make an example. In our example we have the points A, B, 3. These would be 3 places where our structure, this planar surface, whatever it is, a contact or a fault, where this structure is exposed in our terrain, and we see here that these 3 points are at 3 different altitudes. The lowest one is B at 200 meters of altitude, the highest one is C at 600 meters altitude, and we have a 3rd point at 500 meters altitude where our structure is exposed. Since these outcrops are lying on specific altitudes, we also know that the respective strike lines must run through these points. So the 200-meter strike line of our surface must run through point B, the 500 through point A, and the 600-meter strike line through point C. The orientation of these strike lines so far is entirely unknown. If we cannot measure the strike right in the field, which might sometimes be possible, we do not know whether these strike lines would run in this direction, in that direction, in this direction, or in any other direction. The strike could be in any of the 360 degrees. So how can we construct the strike line? There is a very simple technique. The first step would always be to connect with a straight line the exposure at the highest topographic contour with the exposure at the lowest topographic contour. In our case, this would be connecting point C with point B. Since we know that the 600-meter strike line runs through C and the 200-meter strike line through point B, we know that the 300, the 400, and the 500-meter strike lines must intersect somewhere on this line between these 2 points. So let's determine the positions where the 300, 400, and 5-meter strike lines will intersect this connecting line B to C. If we assume that the layer or the structure is indeed planar and has a constant dip angle, these strike lines will be evenly spaced and parallel to each other. And that means that we can place along this line between B and C evenly spaced points of intersection for the 300, 400, and 500-meter strike lines. They will have equal distance between B and C. And this is easy enough to construct. In our example, we want to find these 3 strike line intersections between the highest and the lowest exposure, and that means for 3 evenly distributed intersection points, we have to subdivide the BC line into 4 equal segments. That's what we have done here. 1, 2, 3, 4 equal segments, which means we have added 3 evenly spaced points between B and C. We know that B and C are the intersections of the 600 and 200-meter strike lines respectively, and the 3 points in between are the intersection points of the 300, 400, and 500-meter strike lines. So let's label that. The 300, 400, and 500 are here. The 200 and the 600 we knew before. So again, all we know so far is that at this, that, and that point, strike lines, the 300, 400, and 500-meter strike lines, will run through these points. We do not yet know in which direction they run through these points. Is it this way? Is it that way? Is it that way? For this, we need to consider the third point. The third point A comes into play at this stage. We know from the exposure here at point A that here at 500 meters the strike line runs through, and we have constructed a second point where we know the 500-meter strike line must come through. Easy enough, we just connect these 2 points in order to get the 500-meter strike line. A and this point are both on the 500-meter strike line. This here is the strike. This is the strike of the planar layer that we are looking at. Starting from this point, it is easy enough to complete the strike line sets for the 400, 300, 200, and 600 meter strike lines because we have a uniform dip direction and a uniform dip angle. We just add these strike lines, 600 here, 400 here, 300, and 200. And we label them accordingly. SL 200, 300, 400, 500, 600. Here are our strike lines. Now we are ready to find more points where our layer should be exposed or can be found close to the land surface under a bit of soil or regolith, depending on the exposure situation. Where would the outcrop be? Here comes an important point where many people have made mistakes in the exercises. Many people thought that these points here are also points where the outcrop must lie. This is wrong. They are not outcrop points for a very simple reason. These points here do not lie on the respective topographic contour. 500 here, for instance, is not on the 500 meter contour line. And 400 is also off the 400 contour, and so is 300. Here is the 300 meter contour, topographic contour line. This point is not on that contour line. This means that these cannot be outcrop points. Let's start with the 600 meter contour line. We just investigate the 600 meter structural contour. Here it is. Here it intersects with the 600 meter topographic contour at point C. Nowhere else does this strike line intersect with the 600 meter topographic contour, and that means point C is the only point where we have an outcrop along the 600 meter strike line. Let's inspect the 500 meter strike line. Here along the 500 meter strike line we have, of course, an outcrop here at point A, but we have another point here. At this point we will find our outcrop. Let's have a look at the 400 meter strike line. We have exposure here, there, and there. That is where the 400 meter strike line intersects with the 400 meter topographic contour in 3 different points. Strike line 300 has only one point, and this point would sit here. And along the 200 meter strike line we have again only one intersection on our map. This would be this point here. Nowhere else the 200 meter contour line is intersected. Let's now, for clarity, remove the BC line and the 3 points because they are now meaningless for constructing the outcrop. We have discussed that on the last slide. So let's look at the number of intersections. 1, 2, 3, 4, 5, 6, 7, 8 intersections. That is not an awful lot. So we now can add additional strike lines, and we start with the 350 and the 450 meter strike line. That would sit here for 350 and here for the 450 strike line. Also for these strike lines we can by interpolation construct the position of outcrop of our planar structure. Interpolating where the 300 and the 450 meter topographic contours would be, we get a number of additional outcrop points. So the 450 meter contour would be somewhere halfway between the 400 and the 500 meter contour. And we see here the 500 over here and the 400 runs around here. Somewhere halfway between the 500 that we also see up here, we will find exposure. And this would be certainly at this point and at this point, halfway between the topographic contours. Perhaps there might be another point over here. For the 350 we will find exposure over here, one additional point, and that still is not an awful lot. Let's add further more narrowly spaced strike lines, the 375, the 425 and the 475. Here is the 375, 425 and 475 with additional spacings, and again we can interpolate where approximately the topographic contours would run through and where they would produce intersections. And that provides quite a number of intersections. Let's see. Here about would be the 475 topographic contour. And it also might sit here and certainly also here, 3/4 of the way up between 400 and 500 meters altitude. This point here, because the topography is fairly flat here in this area, this might be a little bit uncertain, but roughly there it might sit. Let's have a look for the 425 contour. That will be here, fairly close to the 400, fairly far away to the 500 meter contour. An intersection is likely to be here, here, and there. And for the 375 also we get 3 intersection points, somewhere over here, over there, and there. Again, about 3/4 the way between 300 and the 400 meter topographic contour. You could add additional strike lines, of course, here. Some with the 325 or the 250 or the 550. You can do that in your own time as you like. But I think for our purpose now we have enough intersections to construct the outcrop line of our planar structure or layer boundary. This is a bit of a tricky section. It requires that you actually understand the topography of the area, which requires careful reading of the topography. You need to know where are valleys, hills, ridges, and so on. And you need to consider the dip direction and the dip angle of the planar structure or layer. We know the dip direction obviously is here perpendicular to strike towards the lower strike line, so we have here something like maybe 220 degrees dip direction. The dip angle you can determine in your own time if you like. It will be a fairly shallow dip angle in this example. There are 2 additional rules that might help you to choose the right orientation for this outcrop line of such planar structures. First, the outcrop line always will systematically follow intersection points from high to low altitude, or from low to high altitude, depending on in which direction you are drawing them. The second rule is the outcrop line can change direction from going downwards to upwards only when the outcrop line crosses through valleys, or from upwards to downwards only when the outcrop line is crossing over ridges in the terrain. Let's have a look at our example. Come here from high altitude, we run down here to systematically lower altitude, and beyond point B we are going to leave the map area. We must come here from altitude higher than 600 meters because we are here on the higher side of the 600 meter strike line. That means also the outcrop must be here at higher altitude than 600 meters. Here we are crossing the 600 meter strike line, and that means that the outcrop also needs to continue at lower altitude than the 600 meters. We are between the 500 and the 600 meter strike line. That means also the outcrop line must be between 500 and between the 500 and 600 meter contour. This is given here. At this point here, we reach the 500 meter outcrop point, and we carry on to topographic altitude that is lower than 500 meter, here to 475, to 450, to 425, and eventually to the 400 meter outcrop here on the 400 meter topographic contour. And so on, we carry on to lower and lower topographic altitude, always intersecting the major 100 meter contours at the outcrop of this altitude here, for instance, at 300 meters. Carrying on at lower topographic altitude towards the 200 meter outcrop, and eventually below 200 meter. We are leaving here the map. What is about these remaining outcrops that we see over here? Think about that we have here a planar layer that is dipping here into southwestern direction. This layer will intersect the hill here on this side. It will run down into this valley, and on the other slope here downwards to point B. This area here is topographically higher. This is a hill on the other side of this valley, and it is very likely that our outcrop also slices through the summit area of this hill. And that's what we are getting here. So here is a second loop of the outcrop of our planar layer. I hope this makes sense to you. This is a fairly difficult example, and I believe if you can manage and understand how to construct the outcrop of this example here, you should not have any problems with any other 3-point problem given to you in the exam. Thank you very much.